Hi, everybody. Welcome to July's Community Office Hour, Building Fast SQL Analytics with Presto, Alluxio, and S3. Thanks for joining us. My name is Amelia, and I will be your moderator. Before I introduce you to our office hour host, I just have a few housekeeping items. All participants are automatically on mute throughout the presentation. If you have any concerns or wish to communicate with me, you may do so by selecting questions from the GoToWebinar control panel located on the right-hand side of your screen. Just type your message or question and I'll be able to see it. I'll be monitoring this throughout the presentation. We're going to have a Q&A session at the end of our presentation so we can answer all of your questions. A reminder to ask a question, just select questions from the GoToWebinar control panel located on the right-hand side of your screen. You may ask your question at any time throughout the presentation and don't need to wait till the end. Lastly, today's office hour is being recorded and will be available for on-demand playback from our website. We'll send you the link follow-up in a couple of days afterwards. That's it for the housekeeping items, so let's meet our host. We're very pleased to welcome Bin Fan. Bin is the founding engineer of Alluxio and the PMC member of Alluxio open source project. Prior to Alluxio, Bin worked for Google where he won the Technical Infrastructure Award. Bin received his PhD in computer science from Carnegie Mellon, working on distributed systems. Co-presenting with Bin Fan is Nakkul Sreenivas. Nakkul is a software engineer at Alluxio, and prior to Alluxio, Nakkul worked as a consultant where he built and supported an entirely open source Hadoop platform for financial services clients. Without further ado, I'm going to pass it on to our speakers.
Hi, everyone. This is Bin speaking. Thanks for the intro from Amelia. I'm glad to be here and talk about how to build fast SQL analytics with Presto and Alluxio and S3. So today we divide this talk into two different parts. I will give a high-level brief introduction on Alluxio and also what data orchestration Alluxio is and how Alluxio can help in the context of Presto and S3. And then Nakkul will start to run a demo, real-time demo, by running Presto with Alluxio on AWS, reading from S3 to show you how this stack works in reality. And later on, we will just take on questions. So whenever you have any question, feel free to ask them in the dialogue. And Amelia will let us know, and we will just start. So, by the way, I like the usually I like the session to be very interactive. So, whenever you see any questions during my presentation on Nakkul's demo, feel free to raise your hands, and we can just try to address your questions in real time. So, about Alluxio, it's open source. It's an open source project started in UC Berkeley and lab, where also Apache Spark and Apache Mesos were brewed. And we have open sourced this project since 2015. And since then, it becomes they grow with a high level momentum, with a high speed growing community. So far, we have more than 1,000 contributors and it's still fast growing. On GitHub, you can find it has been started with 4,000 more GitHub stars. This open source project is licensed under the most permissive license, Apache 2.0, and we have been this project has been downloaded millions of times. So, in a high level, Alluxio is open source data orchestration for the cloud. If you think there is a computation layer and you think there is a persistent storage layer, Alluxio is neither computation nor the storage. Instead, we're adding a new layer into this data stack. So we have the northbound interfacing with different applications, including Presto, Spark, or Hive, or MapReduce, or even the trending big deep learning frameworks like Caffe or TensorFlow. And we provide to these applications, to these data consumers, we provide different APIs. And underneath these APIs, we have one data abstraction. It becomes a data abstraction layer for these applications. So they don't need to understand or even be aware of which physical data store they are talking to, but just talking to Alluxio through either our HDFS API or our POSIX API or even the S3 API. So the data is actually from different data sources, can be AWS S3 or Azure or GCS storage or some other vendors like the boxes from Hitachi or Dell or IBM. And we provide different drivers we call in the southbound. So Alluxio as an open source data orchestration will load this data transparently for the users and cache the data into this layer. So different applications can benefit from reading, when reading from Alluxio, they can benefit from having data cached, the hot data, the working set cached in the Alluxio layer, perhaps in memory, so at memory speed. But also, Alluxio is also providing the file system metadata service. So instead of having going through the slower metadata operation path, Alluxio can help serve the data, the file system metadata. For example, in certain object stores, listing can be slower. But with Alluxio, we have this highly concurrent, highly scalable metadata service to speed up this process. We will talk about this in more details. But in the high level, we provide both on the data path and metadata path a new abstraction layer. So applications can just assume this abstraction. Applications can just assume this abstraction to access data with improved speed. So this is really the sample use cases I'm showing with Presto. We see a lot. So one typical use case is to deploy Alluxio co-located with Presto deployment. In this case, and connecting Alluxio with a backend object store like S3. When Presto is co-located with Alluxio, you get a speed up by having the data cached in the co-located Alluxio worker. So in this case, you don't have to go through S3 every time to retrieve data. So instead, Alluxio will serve the cached hot data to Presto to provide a much better performance and also the round-trip latency. Another case we see a lot is to cache remote data. So you don't have to have Alluxio and the data in the same service. Instead, you can connect Alluxio to read data from a remote, for example, on-premise data, HDFS warehouse. In this case, Alluxio becomes the layer to hide not just the performance, but also the semantics for Presto. In the case I show here, when Alluxio is connected to HDFS and the caching data from HDFS, what enables you is to burst your workloads into the cloud. Instead of waiting for all the resource being available in the on-premise data warehouse, you can launch Presto clusters in the public cloud and reading data from your on-premise data warehouse. And Alluxio can help improve this performance by a lot. And in this way, you are able to leverage the public resource, the public cloud vendor's computation resource, while still leveraging the data in your data warehouse. We call this in the hybrid environment, and this is also very helpful and very Alluxio shows a lot of value in this setting. Talk about a little bit more about how Alluxio can help. We provided improved data locality and also the I/O performance because this is adding a new layer above the cloud storage. On the read case, if data is hit into Alluxio, and it will likely to be served by a Alluxio worker, and ideally its local Alluxio worker is preferred. On the cache miss case, it will serve directly by the cloud storage, but then cache into Alluxio worker in the background process. Alluxio can also work as a write burst buffer, and then synchronously propagate your data change into S3. So we implemented a lot of optimizations to expose the data locality information to applications, so Presto or Spark can leverage this locality information. And also we have a lot of optimizations in serving local applications through the RAM disk or data or through the domain socket. So this can avoid using the network and increase the performance by a lot. I want to show a little bit more details here how data can be asynchronously write into S3 by writing to Alluxio first, and then Alluxio worker return to the client saying, okay, the application has already finished this writing. Now propagate this data into end of store. And this step, so this finished in 2 steps. The first step, application writes to Alluxio and cache into Alluxio and returns without blocking the application. And Alluxio will, on behalf of the application, to write this data into S3, we call the UFS underscore. So the benefits is the application writes to Alluxio at the memory speed, and then the data also gets persisted. We applied a lot of optimizations, including persistent data, persistent files on rename, and this is a particular optimization tuned for Spark or MapReduce like applications, which treats rename as a commit for a lot of different task attempts. And also we also journal the pending async requests to ensure the data will be persisted across different restart. So far, any questions? Okay. On the metadata side, Alluxio provides a familiar operation semantics. For example, listing and rename. These are typically cheaper operations on the file system, but on the cloud storage, they are not file system, although they may provide some similar semantics as file systems. But fundamentally, they're different. They have very different assumptions with different design choices in the parameter space. So implementing a fast listing or rename can be very challenging with the cloud storage. For example, if you have many small objects in a single bucket, and then listing these buckets can be very, very slow. Rename on the file system, traditional file system is just metadata operation. On the object store, a lot of object stores implement rename actually as also data operation. It's a delete after copy. So this can be very problematic with a lot of applications treating rename as their final commits, and also listing becomes also very it's very critical for a lot of SQL engines, because this is during the planning phase they need to understand what are the different files, and they will issue this listing comments. And also in terms of consistency model, object stores typically implement different eventual consistent model. Overriding input is eventually consistent on S3. This can create a lot of issues for applications. So Alluxio solved this problem by providing its own metadata service, just like a HDFS master node, name node, but in Alluxio we call it master nodes. In this way, Alluxio applications talking to Alluxio can continue to assume a HDFS or in general a file system like Semantics in terms of performance and the consistency guarantees. So you get a very familiar semantics implications rather than tuning all the applications to tune for your cloud storage. Optimizations we have here, including modification by passing Alluxio and then resync. So if you have third-party applications or some product team outside your control, changing the data in S3, and then we provide different data policies to resync data into Alluxio namespace. So the metadata will be consistent with what is stored on S3. And also we solve the slow list in object store by, for example, the batching operations. So we know, okay, we can query the understore with a batch mode to improve the performance. And we also leverage off-heap storage, metadata storage in Alluxio 2.0 to solve the too many small objects problem. By doing all this, combining all this together, we can provide a dedicated metadata service on top of cloud storage with familiar semantics and also the fast performance. Specifically, we want to go through a little bit of details into how we implement the efficient metadata operations. For example, the rename a file on S3 can be very expensive, and this is a very common operation for MapReduce-based or Spark-based in applications in their commit phase. So typically, they will write result to a temp directory and then rename this file into final path. But this becomes, on S3, becomes another copy and can be very slow. So with Alluxio async persist, you can write to the temp path to Alluxio in a near real time and get, because this is very fast, in Alluxio space, very fast. And then the next rename from this temporary path to the final path in Alluxio can be cheap renames. This is Alluxio only operation. And then Alluxio will provide a persist operation to propagate this data into to S3 from Alluxio. And we have further optimizations, like we only persist the file on the rename when we see a rename. And this will allow speculative execution from Spark or MapReduce, which we know can, we see for a lot of cases can increase the performance by a lot. So we have more than 100 or even a lot more production deployments with different with companies, leading companies in different sectors. And the largest deployment we have seen for the open source Alluxio is more than even 1,000 nodes. So people are really running this at scale and for a long time. So this is before we go to the next phase for the demo by running the Presto and the Alluxio S3, I want to see if there's any questions from the audience. Okay, so Nakkul.
Sure. Hi, everyone. My name is Nakkul. I think from the intro, I was kindly introduced by Amelia. I also want to just thank Ben for the introduction on Alluxio, so we can sort of get that out of the way. I'll be walking through a demo on basically how Presto works on Alluxio, showcasing some of the performance gains that you get from using Presto on Alluxio, and then also talking about the different options and some of the new features that we have in Alluxio that sort of work cleanly with Presto and offer you a level of flexibility and tuning that you don't necessarily have out of the box. So just to start with, I'm going to pull up the Presto installation that I have. So I've used Amazon's EC2 as the core infrastructure on which I set up this cluster. So just to go really quickly into the Alluxio site properties file. For those of you that aren't familiar with Alluxio, this is the core file in which we do all of our configurations and options, and we specify how the service should run. And this also dictates certain key details that are required for Presto. Specifically impersonation. So we run through the Alluxio master hostname. So these are basically the standard set of settings where you configure the site properties, allowing Alluxio to detail where the master is at any given time, what type of journal that we use, what type of impersonation is configured, and then also the memory size. So as been mentioned, the Alluxio workers do cache a certain amount of data. So I've configured these instances to cache up to 20 gigs of data for each worker. This cluster only has 2 worker nodes, so that means we'll have about 40 gigs of data to cache. Additionally, you'll notice that for Presto specifically, there is a property here that allows Presto users to impersonate. If anyone is setting up Presto on Alluxio, this is a pretty important property. When Presto attempts to talk to Alluxio, it will use the Hive Hadoop connector. And as part of that, it will try and perform impersonation when talking to the HDFS, or in this case, Alluxio. And this impersonation is pretty critical because that's how you retain a level of authorization model from your end user querying Presto to when Presto performs the action or operation on Alluxio. You wouldn't want it so that, for example, if I were to access a table that I'm not supposed to have read permissions on in Alluxio, that I would be able to query via Presto and see data that I'm not allowed to. So configuring the impersonation is a pretty critical property specifically for Presto as well. You do this pretty similarly for most other compute frameworks, but it's something that I think persists across all different frameworks as well. So once you have the Alluxio set up, and I'm just going to make this a little larger so people can see. Once you have Alluxio configured and running, you should generally be able to run a standard ls command. So I'm going to run a simple list command to see, and you'll see that I've actually mounted some TP-CDS data. So this data was pre-generated, and it's in one of our buckets that we maintain on the side. But the point is, this TP-CDS data allows us to basically define a Presto table on Alluxio space and then query this data through Alluxio. This queries we'll actually going to showcase and run through like two different queries, one directly on S3 and one on Alluxio, and then showcase the performance difference. So without further ado, let's go ahead and do that. So first, I'm going to showcase the different schemas that we have. So I have this database configured with scale factor 100 TP-CDS data, and also scale factor 100 TP-CDS data on Alluxio. So any table that you see in the first database is actually defined directly on S3. So we can see that by doing let me see, 1 second, sorry. So for the SF100 schema, you'll notice that the external location currently is an S3 URI. And this URI basically points to the actual location of our data files in the S3 Amazon bucket. Now, if I switch to using the Alluxio database, the schemas have actually been redefined. So you'll notice that this time in the Alluxio database, it points to an Alluxio location. And this location is where Presto will talk to get the data and the information that it needs. And so we can actually see the performance difference when we run a query on S3 versus running it on Alluxio. So if I switch back to my S3 database and I go ahead and I'm going to choose one of the TP-CDS queries to run. I'm just going to pick query 84. And I should be able to just paste this here, and then we should be able to see it run. So when Presto talks directly to S3, there's certain other factors that can come into play. So if anyone has used Amazon S3 in the past, you'll know that different regions will experience different levels of load and latency. So for example, currently this cluster is running on Amazon's US East 1, which is their biggest region by far and also has like the largest variance in terms of performance and response when you run at different times of the day, which is one of the plus sides of running on Alluxio, which is that when you run through Alluxio, because the data is cached locally, you're not dependent on S3's any sort of SLAs or their latency, and your queries can run at a more stable and convincing rate. So you'll notice that this query for query 84 took about 32 seconds. If I run the same query in the Alluxio database via the Alluxio service, we'll see that it takes significantly less time. And this is because the data is currently cached in Alluxio. As the data scale factor gets larger and larger, you can opt to use more cache and you can allocate different things like EBS volumes, or you could even allocate more workers to basically scale up your cluster and then have this run in a much faster amount of time. And yeah, we can see that Alluxio uses approximately 21 seconds as compared to 32. So this is the crux of what Alluxio offers in terms of a performance standpoint, which is that the ability to cache the data locally and skip a lot of the network hops and the cost of the S3 API calls can significantly improve the performance of queries, and it's a very cheap performance improvement, considering all it requires is more operational setup, and it doesn't require users to rewrite their queries. One of the nice things is because I've just redefined my databases and tables, the query actually stays exactly the same, and I don't need to worry about rewriting any of my SQL or any of my libraries that I had. Are there any questions so far, or?
Yes, our first question is how to optimize performance for the stack.
I see. Ben, do you want to take the performance question?
Yeah, so that's a great question. Whenever we deploy some computation stack in production, we will always look for the best performance for sure, right? And for Alluxio, for the particular combination, Presto and Alluxio, there are certain different ways to optimize the performance. For example, how do you set up different block sizes? So in Alluxio, there's the block concept that's the basic unit for Alluxio to cache data, and also it's very important for Alluxio to be able to provide enough parallelism by having a lot of different blocks to the applications like a Presto. So yeah, so one general tip is use a smaller Alluxio block size during your production runs. Also, there are one major, I would say, major thing to look at is whether how much data locality you have achieved through Alluxio, and there are different metrics you can see from Alluxio Web UI or Alluxio CLI. You can check. Essentially, if you don't have a good locality achieved with Alluxio, then your performance will likely to be still bound by network or CPU. But once you have a good locality from Alluxio, that means at least you get benefits from having data cached locally. So that's something I would definitely check as one suggestion. And there are multiple different other aspects you can take a look. So I will show in the end, there's a link in the slides for the performance tuning tips by running Presto on Alluxio.
Great. We have another question here, which is, can we use Hive instead of Presto?
Absolutely. I mean, you could definitely use Hive. I'll actually probably even showcase, I can just take this query, and then I should be able to just run. I'm hoping the Hive service is installed on this cluster. If it is, I should be able to just run this query out of the box.
Semantics might be a little bit different. So
yeah, for this query, exactly. Yeah. But ideally, I should be able to. Okay. So using the SF100 Alluxio. All right, so let's see how far I get.
Oh, okay.
I see.
It's the table. There's some semantics difference between Presto SQL and also the Hive SQL. So I think, but the answer is definitely yes. We have a lot of use cases around Hive, using Hive on MapReduce or Hive on Spark to run on Alluxio. And so basically, Alluxio provides a HDFS compatible interface. That means it doesn't matter you are using Hive or using MapReduce or using Presto. As long as they can query HDFS, you can pretty much use Alluxio there as a drop-in replacement.
Correct. And actually, so instead of running the full 84 query from the TP-CDS suite, I can just show like a standard query where I pull some data, maybe the first 10 rows from the warehouse directory.
Yeah, just do a select. Yeah.
So Hive has already been configured to talk to Alluxio, so you'll notice that you actually do get the same results. So you can see that Hive is able to talk to Alluxio in this case. And the same would go for Spark as well if we were to use Spark. Great. And actually, for Bin's previous question about the web UI, I should be able to pull up the web UI as well. So let me just grab our EC2 URL. Let's go here. Great. So you can see our Alluxio master, and this will actually give us some of the information on how much space we're using. From the data that we're caching when we run our queries multiple times, we're taking approximately 2 gigs of our memory, and of which we have 40 total. And then you can see some of the metrics that Ben was mentioning. You can see details on how often Alluxio does remote reads versus local reads. So considering there's about 2 gigs of data cached and we're doing remote reads for only about 20 megs, I would say that we're doing pretty well. And the majority of the reads are going, and you're getting a good amount of locality. You can see details on the total amount of I/O throughput in the last minute, different reads. So there was a lot of work put into the Alluxio 2.0 web UI, and a lot of that is actually reflected here in the amount of information that's directly available. And there's even more detailed UI if you actually go to the metrics JSON endpoint. And this gives a very low-level detail of granularity with different heuristics and metrics on different API calls, talking to S3, talking to HDFS, and details like that.
Our next question is, if a new catalog is added in Presto, do we need to restart Alluxio?
No, you don't. The catalog, Alluxio does not talk to the catalog. So Presto will talk to the catalog in this scenario. And then that catalog will then needs to be able to ideally sometimes talk to Alluxio. So for example, if you were using a Hive Metastore or you were going to configure a new Hive Metastore, because Hive Metastore needs to have access to the underlying file system to know if a directory exists or to do operations like MSCK repair, or alter table and discover partitions, you would need to configure this catalog with the Alluxio jar, but nowhere in this process do you actually need to restart or reboot the Alluxio service.
And also, I would say like the catalog, you have to configure a catalog to be able to talk to Alluxio. That's very important. For example, you have to configure Hive Metastore to be able to talk to Alluxio. So as long as that is set, you should be good.
Great. Our next question is there any automated mechanism to create or remove mount points in Alluxio by syncing with Hive Metastore? We have been using large multi-tenant Presto Alluxio cluster where we have built additional sync mechanism to create Alluxio mounting and recreated tables which are backed by Alluxio.
I see. So I think for this question, I would ask for a little more detail. So you would need to be mounting multiple S3 or object store locations as new partitions for a table, or is this, I'm trying to understand the use case a little more clearly.
Okay, please go ahead and send us some more information. Yes, new partitions for existing tables.
I see. At the moment, we don't have like a sync mechanism. So like I think the standard workflow would be that you mount a new directory into Alluxio, and then you would ideally have an add partition command run through Hive. So if the request is that can there be an add partition command in Hive that also automatically does the mounting, I think at the moment we definitely don't have it. And I don't know if there's any work towards that. There is work on a Presto Alluxio connector, but through the Hive interface and through Hive Metastore, these sort of changes would be sort of more custom and ad hoc, and not something that I think would go directly into the project.
So I would like to understand. So maybe for the person who is asking this question, you're welcome to join our Slack channel, and we can maybe iterate with this question, because I would like to understand a little bit more why you want to have this automation and what enables you to do, because that's something we're very interested to learn and improve our product. By the way, can we share the Slack channel?
Yeah. Great. So our next question is, can you talk about a real-world use case using the Presto Alluxio and S3 stack?
Yeah, that's a good one. I think well, without getting too specific, one of the use cases that I've seen was so there was a customer or a company that was actually trying to use Presto directly on S3, on Amazon's S3, and their Presto was on premise. It was a cluster that they had set up themselves, and they were paying Amazon a lot of money in terms of Amazon's data transfer fees, and also in terms of Amazon's S3 fees, which they charge for the amount of API calls that you make to the endpoint. So what we did was they installed Alluxio on-premise as well. So Alluxio would connect to S3, and then Presto would connect to Alluxio. And what that meant was if you reran the same query 3, 4, or 5 times, you would only pay for the data transfer fees for once. And then Alluxio would cache all that data locally, and then the next time you access that table, Alluxio would just serve it up from the cache instead of going back and re-downloading the file from S3. And this basically saved them a significant amount of money in their Amazon's monthly billing.
Yeah. So we do have an online meetup. I think it's tomorrow, and in that meetup, it's going to be a real use cases from ING. It's running Alluxio with Presto. I think object store, either object store or it's S3. It's ING is a bank, one of the major banks in Europe. So they will share their use cases tomorrow. And Amelia, can you share the link, the meetup link? It's also an online event. So in addition to that, so actually I had a call, user experience call this morning. It's also very interesting. So what this company is doing is to serve they have a lot of data, terabytes, 100 terabytes of data to scan, and stored in S3. So what they found is once they have some queries from the BI tools to scan these tables, it becomes very slow, and they call this the S3 bottleneck problem. So instead, they put Alluxio into this stack and put Alluxio to cache the hot data their BI queries are gonna query, and then they see order of magnitude improvements in the performance. So we're working with them and try to see if we can make this use cases more public to share.
Great. We have another question here. Will you make an Alluxio connector on Presto?
Yeah, that's a good question. We are working on that. I think it's a very good. So right now, the way Alluxio with Presto is through the Hive connector by asking Alluxio to emulate HDFS. So Hive connector thinks this is HDFS compatible storage service, and we are working on having a more native support to connect directly to Presto, not by just by having data cache, but also working on the metadata part to do some metadata caching and triage to help the Presto queries. Yeah, so that's something we will release very in the near term, basically. Okay.
Those are the questions I have for now. We're going to hang around. We still have some time here, so feel free to send in your questions.
Okay, so I think thanks guys for attending and for all the great questions that were posed. Ben and I are going to hang around here at least until 11 o'clock, so the end of office hours. If you have any questions about Alluxio, not just Alluxio and Presto, but any generic questions about Alluxio or recommendations or any ideas for what topics you would like to see in the next office hours, then feel free to chime in or put a response onto the webinar, and we'd be happy to hear from you guys. Any feedback on today's session would also be appreciated. Thanks, guys.
And as we speak, here's another question. Any updates or improvements to Alluxio GCS integration?
Yeah, I think that's a great question. Sounds like someone has a little bit of insider information as well. So we actually did, our old GCS connector was based on the Jets3T library, which is a now deprecated library, and it seems like Google has now offered and open sourced their API for Java to talk to their GCS file system. So we have written a new connector for GCS that supports the new APIs and has some added support for things like service accounts and authentication via JSON, as opposed to the old Jet3T, which only supported interoperability keys. This new library, I think, hasn't yet been cherry-picked to the 2.x branch.
Actually, it doesn't need to be, because this new GCS connector has been committed into the extension repository. So anyone can just follow the documentation to download the extension and leverage this from the GCS. Yeah.
Mm-hmm. Yeah, so there is a new GCS connector that's coming out, and in order to maintain backward compatibility, we will still be, I think, offering the old GCS connector with the Jets3T and interoperability keys support for the time being, and that may be deprecated probably in 2 or 3 versions in the future.
Awesome. I also have to do a plug here for the Alluxio Global Online Meetup. This is a meetup group that we recently launched, and we will feature a lot of great content. We created this meetup group because we got feedback from folks who are in different regions and really like some of the in-person meetup content we were doing, but unfortunately weren't able to make it. So now a lot of the content will be online, and even if you can't make the exact time, so we've set it for 10 a.m. Pacific time, and we did get questions saying, oh, is it really 10 a.m.? Yes, it is. However, all of the content will be recorded and will be sent out to folks following the event. Thanks everyone for joining us. As mentioned, we're going to hang on the line for another 10-15 minutes. If you have anything you want to chat about, feel free to message us. All right, folks, it's a wrap. We haven't had new questions yet, so we're going to call it a day. Thank you guys for joining us. Enjoy the rest of your day. All right, folks, it's a wrap. We haven't had new questions yet, so we're going to call it a day. Thank you guys for joining us. Enjoy the rest of your day.